component will also be downwards, or will it be upwards?
It will be, I think, component would be in the upwards. No, no, it will be downwards.
Because if the force is coming towards, the component will also come towards. If the force is moving
Okay.
away, the component will also move away.
Away. Okay.
And this one obviously will be W sine beta. And what will be
Okay.
the direction? Is it upwards or downwards?
It downwards. Not.
Downwards. Yeah. Because the force is again, it's coming towards. So both the components will
Okay.
come towards.
Okay.
Fine.
Yes, sir.
So this is finding the components. And let's see
Okay.
what else is there. Resultant from x and y components. So if you find all the sum of all the x components, so this method is used for combining a number of forces. So if you have a number of forces acting at a single point, okay,
Okay.
then how to add them? So one method is to use the polygon law, which is the graphical method. Yeah, but I don't suppose
Okay.
are you supposed to carry instruments and draw with measurements?
Carrying instrument in the sense what, sir?
Drawing
Like
instruments
scale?
like scale, compass, and all.
Yeah, we can carry that.
So if you want to use the graphical method, then you have to carry your instruments, and all these forces you need to draw them in continuation. So first force, second, third, fourth, and fifth. So first is acting in this direction, the second one is acting downward. So from here we have to take the same measurement in downward direction. This is 2.
Okay.
Then third is moving in this direction, so parallel to the third one we have to draw it. And fourth is moving upwards in this direction, so fourth one we have to draw like this. And fifth one is moving in this direction. Okay, got it?
Yes, sir.
So all the forces we have to draw in continuation. Then the resultant will be given by the starting point and ending point. So this
Ending
will
point.
give us the resultant. Okay.
Okay.
So
Okay.
this is the graphical method. This is the graphical method, also called analytical method.
Okay.
Not analytical. I think this is graphical method. Analytical means we have to do with calculations. Yeah. Analytical means we have to do with calculations. So what we have to do is we have a parallelogram law. You know parallelogram law?
Parallelogram law. Just
So this
you
that
might know.
the parallelogram law itself is giving it as the law of cosines. The law of cosines tells us that if two forces are known, let us say we have two forces, one force is P, the other force is Q, and you are supposed to find the resultant of these two. Okay, if you are finding a resultant of these two, we can find it as the diagonal of this one, correct?
Okay.
This diagonal is given as resultant, and according to the cosine rule, we know that r square will be equal to p square plus q square plus 2pq into cos of the included angle. The included angle being, let us say, alpha, theta. Okay. So this is the parallelogram law. But if you want to use parallelogram law for these forces, then two forces at a time you have to take.
Yes, sir.
Two forces at a time you have to take, find its resultant, then take resultant and one more force, find its resultant. So it's a very cumbersome and long process, right?
Yes, sir.
So that is where we use the divide and rule method. Okay. So what we can do is we can divide every force into a vertical component and a horizontal component.
Yes, sir.
Then all horizontal components can be added up.
Yes, sir.
And all vertical forces can be added up.
Yes, sir.
Once you have the vertical and horizontal components, you can find the resultant by combining them back. So the included angle here is 90 degrees. So cos 90 becomes 0.
Yes, sir.
We are left only with sigma x square plus sigma fy square. And r square is equal to this. So if you want r, you have to take square root of this. Okay.
Square root of that, yes, sir.
So that's the formula for resultant. So that is magnitude. And direction. For direction, we have to find its angle with horizontal, right? So horizontal component is fx, vertical component is fy. So how to find alpha? Alpha will be
fx cos alpha,
it will be
or
tan
f cos
tan inverse.
Tan inverse. Okay,
Tan inverse
angle. Okay.
opposite by
Opposite by adjacent.
So what is the opposite here?
So opposite is Fy
Y.
divided by Fx.
Okay. So this is called direction. This is called
Direction. Okay.
so direction, you can say. So cos alpha, if you know the value of f and fx, you can use cos alpha. If you know fy and f, you can use sin alpha. Or if you don't know f, if you just know fx and fy, you can use tan alpha. Okay.
Tan alpha. Okay. Yes.
Then you have static determinacy in the planar systems. Okay. So if you want to find degrees of freedom or links, this is from kinematics. So number of bodies, number of support reactions, number of joint reactions. What is this? We come across this, but in a slightly different way. I don't know what is this. A and Z. What are A and Z? Support reaction. What do you mean by support reaction?
So support reactions and support reactions. This like beams and those stuff. So
So suppose we have a beam. Let us say we have a fixed reaction here. The
yeah, those.
roller support
Yeah.
here. Okay. So how do we
Yeah.
implement that equation? You want to find degrees of equation. He is telling 3n minus a plus z. Okay. So f is the degrees of freedom. 3n. What is n? N is the number of bodies. How many bodies are there? So should we count them as 3 bodies?
So this one is also. Oh, sir. Sir. Like this one is for this
Mechanisms.
truss
Yeah, this is
truss
a.
mechanism.
But for
This is
truss,
for
this is the equation we take here slightly differently. Suppose you have interconnected system of bodies. Yeah. So then we find the degrees of freedom. We find the degrees of freedom, or we call it as mobility here. So we take it as 3 times L minus 1 minus 2J. This is the equation we use here. Where L is the number of links. L is number of links. So in your book, it is called as, it is been stated as number of bodies,
bodies.
number of
Yeah.
bodies here. So here we call it number of links, and J is the number of binary joints. Binary joints are the joints where 2 links are connected. Right? So in this mechanism, for let us say we have 4 number of joints, 1, 2, 3, and 4 joints, and we have 4 links, 1, 2, 3, and 4 links. If we substitute these values in the equation, we will get 3 minus 1 minus 2j. 2 times how many are j? J also is 3. So 3 to the 6, 3 to the 6. So we get, oh sorry, we made a mistake here.
So, there are 4 joints, right?
Yeah, 4 joints. So 4 minus 1 here. So 3 3s are 9 minus.
There are also 4 joints, right?
4 joints. 8.
8.
So that means we have 1 degree of freedom. When I say 1 degree of freedom, I mean that if I move any one link, the other links have to move to keep up with it. To keep up with it. Okay. So there is only one position possible for this, and that position can be controlled by any one link at any given point of time.
Yes.
But I don't know what this equation is. This equation is slightly different. Maybe you can just take a look at it later. These are standard angles. Are you not? I mean, are you supposed to calculate? I mean, can you carry calculator?
Yes, sir. For this, I can carry calculator.
Yeah. Then why is he giving standard angles? It's not needed, because you will directly get all the values from calculator, right? But anyway, in any case, I'll just tell you. You know the table methods.
Yes.
What is cos 60?
1 by root 2.
1 by root 2. By root 2 or 2?
1 by root. So
Okay,
1 by root 2.
I'll tell you a small trick to remember this. Fine. The whole table is a bit tricky. And
So
so
if I tell it from beginning, then I will.
that's the problem. That's the problem with this. Okay. So if you want to be able to guess from the middle anywhere, then you should remember these two diagrams. Okay.
Okay.
So if you remember these two diagrams correctly, then you can recall any angle, any ratio.
Okay.
So this angle
Okay.
is 30-60. This is 45. Okay.
Mm.
So in 30-60 triangle, if this edge this is 1, then hypotenuse will be 2 times of that. Okay.
Mm.
Hypotenuse is always double of this length. Okay.
Okay.
Now what will be
Yes, sir.
this? How much will be this?
Um, Sine. No, no,
Pythagoras
no.
Pythagoras relation.
I, yes, sir.
So 4 minus 1 under root now. Under
Yes, sir.
root 3. Correct?
Huh?
2
So
square minus 1 2
yeah.
square minus 1 square under root now.
Yes, sir.
That is root 3.
Root 3. Oh, okay, okay.
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 So and here when the angle is 45 degrees, these two edges are equal, right?
Yes, sir.
That's why we can take them as 1.
Okay.
Now again use Pythagorean relation. What will be the hypotenuse?
Hypotenuse will be 1 square plus 1 square. Root of 1 square plus 1 square. Okay.
That is how much? Root of 2.
Root of 2. Yes.
Now if you remember these two triangles, you can easily tell all the ratios. Fine. So suppose you want
Okay.
sine 30. Sine is opposite by
Hypotenuse.
so now for 30 what is opposite
1.
and what is the
1 by
hypotenuse?
2.
So sine
1
30
by 2.
is 1 by 2.
1 by 2. Okay.
If you want cos 30, cos is adjacent by hypotenuse. So adjacent is
Yeah. So root 3.
and hypotenuse
Root 3 by 2.
root 3 by 2. Suppose you want sec of 45. So sec of 45 is 1 by cos 45, no?
Yes, sir.
And cos 45 is adjacent by
Adjacent by hypotenuse. 1 by root
1
2.
by root 2. So 1 by root 2. Okay. So if you remember these two, then you can recall all the ratios of 30, 45 and 60. Got it?
Okay. Okay.
And there are two more angles, right? 0 and 90 degrees. How to recall for 0 and 90 degrees? You will remember.
So if one is 0, the other one is 1.
Okay, this is a simple triangle. Actually, this triangle will overlap exactly. Okay? So this is our default 90 degrees. This angle, let us assume it as 0 degrees. This angle, let us assume it as 90 degrees. Okay.
Okay, sir.
If this is followed exactly strictly, then the lines will overlap. You know? So this length will be equal to this length. And this length
Yes,
will
sir.
be 0.
0. Okay.
Okay. So this 0 degrees, I'll just write inside so that it is clear. Okay. So now if you want sine of 0, again sine of 0 is opposite by hypotenuse.
Hypotenuse.
So 0 by 1 is 0.
0. Yeah.
Okay. So if you want cot of 0 is 1 by tan 0. Tan 0 means opposite by adjacent.
Opposite by adjacent.
So opposite is 0 by adjacent.
0, 1. Yeah.
1 by 0 is
1. Infinity.
okay. So if you remember these three triangles, you can recall any ratio from that. Okay.
Okay.
Got it?
Okay, sir.
And what if the angle is greater than 90 degrees? Suppose you want to find 120.
Okay.
How to find? You have to write it as 180 minus some angle. 180 minus how much is 120?
180 minus 60 is 120.
So in the second quadrant, sine is positive, so you will get positive sine 60. Okay. So from here you just remember the diagram. For 60, opposite is root 3.
Root 3.
So root 3 by 2. Okay.
Okay.
Suppose you want to find some angle like cos of 150. How will you find cos 150? Once again, you have to write it as 180 minus
180 minus 30.
30. In second quadrant, cos is negative. So you will get minus cos 30. Okay.
Yes, sir.
So from here you remember the diagram and you can follow from there. Adjacent by
Hypotenuse.
adjacent is root 3, minus will remain as it is. Adjacent is root 3, hypotenuse is 2. Got it?
Root 3 bit. Okay.
So if you remember these three diagrams, there is no need to write the whole table down from beginning. Okay.
Yes, sir. Okay.
So, but it will take some time. Initially, you will face some difficulty because you have to remember the triangles, right? So, for about 10 to 15 times, if you draw the triangle and if you are able to do, next time onwards, you will directly be able to imagine the triangles, and as soon as you are asked some value, you will be able to tell it. Okay.
Okay.
Logically, you can remember. There won't be any confusion or any doubt. Right? With the table method, what happens is you will get doubt. Is it 2 by root 3 or root 3 by 2? Fine.
Yeah. Yes, sir.
For,
Okay.
for
Okay.
cos 30 or cos 60, some other doubts will be coming up, right?
Yes,
So
sir. Okay.
this will not give you any doubt. If you remember the triangles easily, then you can find it because you already know about the ratios, opposite by hypotenuse and all those ratios, you know it. You can easily find it.
Okay.
Then centroid, okay, centroid we are doing it with the table method. I'll tell you about the table method when we are doing the problems. And we have here resultant of distributed loads, I think. Okay, so the remaining formula we'll take up in the next class. So let's start with the session 1. Let us see what we have here.
Session 1 is only basics, like basics of
Only theory is
stack.
covered. So here reactions. So here you can see the left side reaction is there. It is a rolling support.
Rolling support.
Because it's a rolling support, only vertical reaction it will get. But the right side one is fixed with the base. So we will get two
Both
reactions.
horizontal and vertical.
Yeah, both horizontal and vertical. Then strength of materials, you shown here the what is that? Shear stress, right? Shear stress will be acting like this. Right. Then what do we have here? Dynamics and kinematics. So how the objects are moving. So trajectory of the path. If your object is thrown in the air, then the path followed by that is called as trajectory. Right?
Yes, sir.
And for a free falling body, what is the shape of the trajectory?
It's like a
Parabola.
parabola.
A parabola. Okay. Then for rotating objects, we have revolving velocities and all. Then dynamics, kinematics. Once again, we have velocity, acceleration. I think you need to know about the relation between velocity and acceleration. Acceleration is rate of change of velocity, and velocity is rate of change of displacement. All those reactions will come up here. Then force. What is force?
Force is a physical quantity that can be brought into equilibrium with gravity.
Oh, it's a very specific thing. But in general, force is anything which either generates motion or changes the shape of the body. Okay.
Generates motion? Okay, yeah.
Fine. Either it will generate motion when you apply the force, the object will start moving. Okay. If the
Or
object
it
is
will change the shape of it.
or else it will change the shape. Fine. Rigid body
There
shape.
are but there are equal forces too, right? Like opposite forces,
If there are opposite forces, they
that's
will
not
cancel.
doing anything.
Yeah.
They cancel each other, yeah.
Yeah, will cancel each other and the body will come into equilibrium.
So
he's just talking about equilibrium here. Yeah.
Okay.
But force in general, the definition of force is anything which either generates motion, modifies the motion, or changes the shape. Yeah. So one of these things it will do. When I say generate motion or modify motion, motion may be the direction of velocity, even direction of the velocity if it changes, then also the force will be acting. If just magnitude of velocity changes, then also force will be acting. So if the object is moving in straight line with constant velocity, only in that case there won't be any force acting on it. So the object will be in equilibrium. Okay.
Okay, sir.
Then weight force is m into g, because the second law of Newton, it says force is equal to mass into acceleration. The same equation we are applying here because the acceleration due to gravity is g. So we are just replacing that with F equal to m into a. This is Newton's law, right?
Yes, sir.
So for free falling objects, weight, force will be equal to weight, mass remains as it is, acceleration will be equal to g. That's what he's telling you. We have the magnetic force. Okay, this is A is pole surface area, B is magnetic flux density. So B is some constant. Actually, mu naught and mu are some constants. Magnetic permeability and magnetic permeability of the attracted body. Magnetic flux density is a quantity which most of the times will be given in the problems. If you are given a problem, you will be told the value of this. Okay. Then electrostatic force. Electrostatic means if you have a proton or neutron will not have any charge on it. So electron proton or proton proton. Yeah.
Yes,
These
this is the
charge.
first will this is the formula we use it for electrical engineering. Like
Yeah.
this
Electrical.
one.
Yeah. Electrical of course. The upper one is for magnetic force. This one is for electrostatic force. Then we have point lift. Point lift is rho into volume into g. Rho into volume gives us mass into gravity. Okay. So buoyancy force. What is the buoyancy force?
Force.
So if you put some object in water, yeah, and if you take its weight,
Okay.
will it be same as when it is outside or will it be less?
It will be less.
Yeah, less. So objects feel lighter when they are submerged in water. No? By how much amount? By how much amount do they feel lighter?
It depends on the density of the water, sir. Like the
Not
liquid or
not density of water. It depends on how much water is displaced. Okay, water how much is displaced.
displaced.
Yeah.
Okay.
So if you see the weight of the water that is displaced, that will be subtracted from the weight of the object, and that weight you will get here. Yeah.
Okay.
So the upward force that is acting, which is called buoyancy force, that force is equal to the weight of the water which is displaced. Okay.
Okay. Okay.
In fact, this is how Archimedes had found the problem with Crown. Remember the story? Have you been?
The what, sir?
There was a scientist, Archimedes.
Archimedes, yeah.
So this is called Archimedes principle. Buoyancy is called as Archimedes principle. So the king
Okay.
had told him to find whether something is mixed in the gold.
Okay.
Right? And he had told him that he'll be beheaded next day if he doesn't find it out.
Okay.
And the whole day was in tension and he was looking for all the different methods. He tried everything. The weight
Okay.
of the pure gold and this crown was equal. Right? So then he was in a total fix how to solve it. He doesn't know how to do
Okay.
it. Then when he was taking the bath, he understood. He filled the tub with water. Then he went inside the water. He felt lighter, and some water came out of the tub. Okay,
Okay.
and that's when he understood. That's when he found the principle of buoyancy.
Oh, okay.
Right. So it is said
Okay.
that he started running into the street shouting "Eureka, Eureka!" Eureka means
Oh.
got it, got it.
Okay.
Yeah.
Okay. Okay.
And so that's the
Yes.
story with buoyancy and dynamic lift. So an aeroplane wings, they give a lift to the aeroplane, right? That lift can be found by this formula. All the values have been given here on the right. CA is the lift coefficient, and rho is the density of air, A is the surface area, and V is the velocity of the plane. Okay. So CA will be constant for air. That value will be given either, or you may be able to find it from some constant book or something. Can you carry some logbook or anything?
No, sir, I don't think so. They're allowing logbook.
So you told that you can carry papers with formula and all, right?
Yes, sir. Like,
You can write
we
that.
can
Yeah, you can write that
logbook
value.
also. But yes, sir. But so before we are going inside, they will check like what we are taking like in like
Okay, so not everything is allowed.
yeah, logbook. I never like in statics. I don't think so. Like people use logbook.
So maybe then they should provide the value in the question. Okay. CA value they should provide in the question.
Yeah, that they will provide, I guess,
Okay.
if they are asking it.
Fine. Then again, aerodynamic drag. This is very similar to this drag. Fine. So lift will
Mm.
be pushing the aeroplane up. Okay.
Mm.
Whereas for cars, we need to have an opposite force. Okay.
Yes.
Why do we need opposite
Yes.
force?
Because then only the car can move the
Now
resistance.
car will move. Now car will move.
Friction.
Even if the downward force is not there, gravity is there anyway. Weight of the car is acting already. Yeah.
Okay. Yes, sir.
Then this is putting an extra force in downward direction. Why is this extra force needed?
For the car to move faster.
Faster means engine has to be faster.
So so what you're saying is that the car needs a downward force.
So downward force is created for the car, especially the
Okay.
racing cars and all.
Yeah.
No, the backside some bonnets will be there now for cars.
Yes, sir, that's what I meant. So
Mm.
it gives like
So that pushes the car downwards. Why do they need
downward,
to push the car downwards? That's my question.
so that it gets more friction and then the car
Yeah.
can
Yes. 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 Very
move,
good.
move
Very
faster.
good. Friction force. Friction depends on what? What is the formula for friction?
So mu not something.
Mu into normal reaction. No?
Mu to remuneration.
So this value is constant for given surfaces, right?
Mm.
This is the normal reaction. So the more force we add, the more will be the normal reaction. No? And if
Yes, sir.
normal reaction is more, we will get more friction. Without
Mm.
slipping, the cars can move. Okay.
Okay.
And racing cars, especially racing cars, they need to take turns at a much faster speed, right?
Yes, sir.
When
Like
the car is taking a turn like this, then there will be an outward force, force of what's
and
that? Centrifugal force, right?
centrifugal force, and there's a chance of slipping
Yeah,
also.
there's a
That's
chance of slipping. If you don't want it to slip, then you need more friction, right?
yes, sir.
So that for that purpose only they put this bonnet for downward force. Yeah,
Mm.
and this force is so high that no, on a discovery program we had been shown once that if there is a tunnel, yeah,
Mm.
if there is a tunnel, the car can move upside down. The car can move
Upside down.
upside
Oh.
down. Fine. When it is moving
Mm.
very fast, it can move upside down, and it will be
Mm.
overcoming all the gravitational force, and the push is so high that it will be touching the roof.
Yeah. Okay.
It's
Okay.
that high.
Mm.
Yeah,
Mm.
it's not a joke. Fine. So this is clear. You can
Yes, sir.
see the formula is same. The formula is same. Instead of just CA, we are getting CW. Fine. Remaining everything remains same, right?
Mm.
Then we have the section force. So section force. This is a simple.
So just a moment. Yes, sir. I'm sorry.
So you know the formula for pressure?
Force into
Pressure is force by
force
area,
into
na?
area.
Force by
Yes,
area.
sir. Force by area.
So more is the area, less will be the pressure. Okay?
Force area less will be the force. Exactly. Yeah.
If you have a stone and if an elephant is putting its paw on this stone, it may not break. Fine. But a lady, fine, a very health cautious lady, if she just puts her shoes on the stone, then it may break. Na?
Yes, sir.
Because what is happening here is area is low. Area is low. Okay?
Yes, sir.
Because area is low, pressure will go up. Whereas here for the elephant's leg, even though the force is very very high, weight of the elephant is very very high, but here area is high now.
Yeah.
Because area is high, pressure will come down. This is the relation which helps us analyze this. Okay.
It's also similar to people walking when there are like a lot of if people can easily walk in a lot in a nail bed because there are a lot of nails, but if there is just one nail, it will poke them inside, right?
Oh yeah, that is also the case. Yeah.
Yeah.
Number of nails are there, so weight will distribute on that, right?
Weight will get
Yeah,
distributed.
weight
Yes.
will be shared by all the nails, so they can easily walk. So next is just explaining all the theory. Force is a vector quantity. We have discussed this while studying dynamics, right?
Yes, sir. Session one is full of theory and basics. From session two, there are formula. There are problems.
Quickly go through all these. We already know about this.
Mm.
Classification of forces. We have one dimensional, two, three. Okay, classification by interaction. Okay, according to area of action. Okay, internal forces and external forces. Okay, freeing, cutting, and isolation. Yeah, free body diagram. You know what is free body diagram?
Free body diagram.
Hmm.
Yes, sir.
What is it?
So, like, if they are giving us a problem with a diagram,
Hmm.
we will uh, we will make it easier for us to calculate by
Because
actually writing the force.
what it will do is a different thing. I'm asking you what is free body diagram. So in free body diagram, we replace supports. No, whatever supports are there, we replace them with equivalent force.
Equivalent forces, yeah.
Yeah. So whatever supports are there, it can be a thread, it can be a physical support. So we are replacing them with their equivalent forces, right?
Yes, sir.
So then once we have all the forces, we can apply the laws of physics, right? Laws
Yes,
of
sir.
equilibrium to analyze the forces. Graphical visualization. Mm. Okay, so force polygon we have already I already told you, no, just now. Right? Wasim,
Yes, sir. Yeah.
the force this one polygon I have already explained, right?
Mm.
The same thing he has given over here, right? We
Yes,
just
sir.
have two forces here. We can see the
Mm.
resultant. Here we have more than two forces. We'll get a polygon with the resultant.
Yes, sir.
Okay, so yes, we can go for the problems. Let's see. So session 2, right?
Yes.
So session 2. Okay, so we have a question here. Ready? The shaft is subjected to three forces. Let me quickly take its snapshot. Mm, So shaft is subjected to all these forces at
Mm.
3 kilonewton. F1 is 3 kilonewton, and then beta 1 is given as 30 degrees. Then F2 value is given as 4 kilonewtons. Beta 2 value is given as 45 degrees. F3 value is 3 kilonewtons. Find both magnitude and direction of the resultant force with the parallelogram law of forces. So according to parallelogram law, what we have to do, we have to take first force like this. This is F1, right?
Mm.
And then the second force is going upwards here like this. No,
Yes,
F2.
sir.
And wow. Third force has to come down. So one is going down with the second is going. But this will give us the resultant, right?
Mm.
Madam is asking us to use the parallelogram law. Okay, so parallelogram law, if you have to apply, then you should consider this one as resultant. Okay.
So can we use this? I don't know. I learned it before, but can we use this Lame's theorem
Yeah, we can
to?
use it, but he is specifically asking us to use parallelogram law. Okay.
Mm.
Lami's theorem also we can use. Lami's theorem we can apply only when there are exactly three bodies and the object should be in equilibrium. Okay.
Oh, so this object is not in equilibrium. It's in equilibrium, right?
No, 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 no. He's telling it's not in equilibrium. That means we have to find the resultant, right?
Mm.
So even I made the same mistake. So this is not resultant. This is not the resultant. So we know three forces given randomly. Okay. The values of all the
Mm.
three forces and directions have been given to us. And he
Okay.
has asked us to find the resultant of all the three forces. Okay.
Mm.
We are supposed to find resultant of all the three forces. So now there are a number
Mm.
of ways to do that. And so one way is to find the components of forces, add all the horizontal vertical components. That is one way. Okay. But he has asked us to use the parallelogram method. Specifically, he has asked us to use parallelogram method. We'll have to go
Mm.
with that method itself. So here what we have to do is, so let's take F3 and F2 first. Let's take F3 and F2 first. So the parallelogram formed will be like this, correct?
Mm.
And the resultant will come out like this, right? Because both the forces are going away, this will also go away, right?
Mm.
And then we have to use the parallelogram law for these two forces, F1 and this resultant. आता है, क्लास में क्या होगा? क्लास के बाद आता है? Then this resultant and this F1 force, we have to find resultant for those two. Yeah.
Mm.
Let's first find this. Now, what is the included angle for these two forces?
It's 45 plus 90.
45 plus 90. So the forces are 4 square plus 3 square plus 2 times 4 times 3 into cos of 90 plus 45, right?
Yes, sir.
So this is, we have to take under root for this, right?
Mm.
So what will be this? Use calculator. Find it.
4 square plus 2 square plus 2 into 4 into 3 into cos 90 plus 45.
मम्मी को दे दो. Okay, so found it.
2.83, sir, or 84, 2.84.
4 square plus 3 square. Got the exact value? Do I need to check it or you're confident?
Confident, sir.
Okay, let me check it. Cos 45. So 6.48.
6.48.
How much
I
did you
don't
get?
know why. What's wrong with my 4 square plus 3
No.
square plus
Did you
2
take square root?
into 4 into, yes, sir, I do. 3 into cos 90 plus 45.
How much did you get?
I'm getting 2.84, sir.
2 cannot be possible.
Sir, like, I don't know, like, something wrong with my calculator or what.
1 minute, 1 minute. I think I made a mistake. Yeah, 45. It's not 45, no? It's 90 plus 45.
Yeah,
My mistake. 2.83, correct.
yeah, 2.84.
So I took cos 45. That's why it came out. So 2.83.
84, sir.
833 is coming for me. So
Okay, okay.
so that is the magnitude of resultant. And about the direction, let us say this. Let us say this is the angle we want. Alpha will be equal to f2 into sine of 90 plus 45 divided by f3 plus f2 cos 90 plus 45. Okay, so this value you have to substitute. Go ahead and do that.
Sir, but I don't know why they are asking parallelogram of forces, but if you use the Lami's theorem, it will be much more easier, right?
Lami's theorem we cannot use because he has not told that the object is in equilibrium. Okay.
Okay.
Lami's we cannot
So,
use. Lami's cannot
so
use.
to
Because
use the Lami's theorem, it has to be in equilibrium.
yeah, it has to be equilibrium. That means resultant has to be 0.
So here the resultant is not 0.
Yeah, it's not 0 because he's asking us to find the resultant.
Oh, okay, okay, okay.
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 So the best method here would be to use the components method. कैमरा बंद है. अब तुम बाहर जाओ ना. Okay, so solve it.
And one
It's
more.
really very complex
Yeah.
actually. Yeah, even I feel it's way more complex.
So yeah, but so can we use this this x component and y component method?
Yeah, that will be the easiest method. And I usually teach with the table method. Let me table method. Simple. Table is very simple. So we just need to take the force. Then we need to take horizontal component, horizontal and vertical components. With this we can find it. Okay. So what is the first force? Let us take 3 kilonewton as the first force. It is acting downwards. 3 kilonewton. So vertical component will be -3, right?
Yes, sir.
Horizontal.
Horizontal.
0, no?
Yes, horizontal. Yeah. Okay. This. Okay. Yes, sir.
Then we have the next force, 4 newtons. So this is acting at 45 degrees, right?
Yeah. So 4 cos 45. Vertical. No, sorry. Vertical is 4 sine 45.
4 sine 45 positive.
Yes, sir.
And
Horizontal is 4 cos 45.
4 cos 45 positive again.
Yes, sir.
Then the next force is acting downwards. And this angle is with horizontal, right?
Yes, sir.
So vertical.
minus 4.
Value is
Uh,
3 kilometers.
yeah, sorry, minus 3 sine
30.
30
Hmm.
minus
This
3
this one is
cos
positive.
sorry, yeah, this is plus 3 cos 30.
Okay. Now you
Mm.
just need to add them. So sigma v, sum of all the vertical components, you add this, you will get it. And if you add
So it
these,
will
you will
be,
get sum of all horizontal components.
yes, minus 3 plus 4 sine 45
Hmm.
minus 3 sine 30. It's minus 1.67.
Minus 1.67. What about horizontal?
4 cos 45 plus 3 cos 30. 5.42.
8 point.
5.42, sir. 4 cos 45 plus 3 cos 30.
5 point.
5.42.
So now that we have both of these, we can easily find the resultant.
So it will
Resultant
be,
square of this plus square of the other. What do we get?
5.1.
5.1. It will be greater than 5.4, no? Slightly greater, can be less. Minus will get cancelled. Have you taken minus?
Yeah, the minus will get cancelled here.
5.67 I'm getting.
So 1.67 the whole square plus 5.42 the whole square. Yeah, 5.67, sir. Yes.
So this is the magnitude.
Mm.
Okay. Then about the angle, we have to take alpha equals. Now here we know both vertical and horizontal components.
Yes, sir.
So tan inverse sigma v by sigma h. Right?
Mm.
What do we get? Sigma v is this one, 1.6 by 5.4, 5.42.
I'm getting minus 17.12.
Don't take minus 17.12
12. Mm.
degrees. Okay. So now we need to find the quadrant, in which quadrant it is acting. So if you see the vertical component, it is negative, you know,
Mm.
and horizontal component is positive. You know?
Positive.
The
Mm.
resultant will be in between these two,
Mm.
and the angle will be from horizontal.
Mm.
So resultant magnitude is 5.67, and its angle from horizontal axis is 17.12. Okay,
Mm. Mm.
that's the result. If we use parallelogram law, it will be very very tough.
This is the easiest method we can use, sir.
Yeah. I don't know why he kept parallelogram law. Maybe, you know, if he cuts the marks for using different method, then it will be a problem. Once confirm from your lecturer if he's telling you,
Okay.
if you can use any method, then okay. See, he
So
has
he's getting the same answer, sir.
here answer will
5.7.
be same. Answer will be same, but you can see here he is using the parallelogram method. Yeah.
Mm.
What he has done is he has transferred this force here. So this law is called transmissibility law. What the transmissibility law, what it tells is that you can transmit a force. You can transmit a force in the same line in like this. Okay,
Mm.
you can transmit the force anywhere in the same line.
Okay.
So he's first transmitting the line here, then he's taking the he's using the parallelogram law with first with these two forces, then with the other two. Yeah,
Okay, sir.
you can just confirm from your lecturer if you can use any other method, because in this case specifically he has mentioned parallelogram. Okay,
Okay, sir. Mm.
and then here 4 ropes are mounted on the pylon. Forces on the ropes are given. Determine the magnitude and direction of the result. So here definitely I think he has not asked anything, right? He has not mentioned which method to be used. We can follow whatever method we are comfortable with.
Yeah. So this we can find easily, yes, sir.
Again, we can use the table method. Again, he has used the parallelogram method. Okay.
So can you explain me the parallelogram method with a simple problem?
Shall we do the upper one itself?
Like, but this one is complex. Can you
And
explain me
this
the
this
parallelogram law of parallelogram method?
this is simple actually. Simple. Let me explain. Let me take this diagram. Ready?
Yes, sir.
What we have to do first is we have to remove this from here and we have to take it along the same line. Okay.
Okay.
In the same line, along the same line, you need to take the force here. Okay.
Okay, sir.
So we can remove this force and we can put the same force here. So this force is how much? This force is F1. F1 is how much?
Mm.
F1 is 3.
3.
F3 is 3. F2 is 4. Right?
Yes, sir.
And then this angle is 45 degrees. And because this angle beta 2 will come here now.
Yes,
This
sir.
is 30 degrees. Right? Now we need to find
Beta
the
1, sir.
beta 1, of course. Same will come in this side also, right?
Mm.
Now we know both the forces. We know the included angle. We can apply parallelogram law. Right?
Okay.
The first parallelogram law we have to apply on these two forces. So we have to complete the parallelogram. Then we have to draw this. Right. So this is the resultant. Now
Okay. Mm.
to find the resultant will be equal to 4 square plus 3 square plus 2 into 4 into 3 into cos of angle. What is angle? 45 plus 30.
Yes,
Correct.
sir. Mm.
So this entire thing has to be taken under square. Find it. Finding the angle will be tough here. Let's do this
Yes.
first.
Mm.
4 into 4 plus 3 into 3 2 into 4 into 3 so cos how much?
1 minute, sir. 5.5.
5.586
5.8.
so 5.9.
Okay, yeah.
So this is the magnitude.
Mm.
Then we need also the direction, right?
Yes, sir.
For direction we'll have to take it from one of the forces. So let's take it from this force alpha. So for alpha we have to take 4 4 into 4 into sine of total angle. Total angle is 45 plus 30, right?
Mm.
Divided by 3 plus 4 cos same angle. You know this formula?
No, sir, it's new to me.
This is tan of the formula. Let me explain it like this. So suppose you have two forces. One is P, the other is Q. Right?
Mm.
Then you'll have to draw the parallelogram. Then this is the force, right? So this is angle alpha. So tan alpha, if you take tan alpha, if you take, it will be equal to this opposite by this total adjacent, right?
Yes, sir.
So opposite length is what is it? Q into sine theta.
Yes, sir.
Q sine theta divided by this total length. So total length is this plus this, right?
Mm. Yes.
So this length is P, no?
Mm.
So P plus
Plus
this length is Q cos theta, right?
Okay. Got it. Yes, sir. Okay.
So that same formula I'm using over here, right?
Okay.
So if you want to find alpha, you have to take tan inverse. So take tan inverse and find what is alpha.
1 second.
4 into sine much angle 75 divided by 3 plus 4 into this cos alpha inverse answer. Right. How much?
66 point.
No, getting
Why?
43.76.
Just 1 minute, sir. I'll try it again. 4 sine 45 plus 30
Forty-five
divided
plus
by
30, 45 plus 30 is 75. No, we can directly put it.
yeah, plus 3 plus 4 cos 70. Okay. Uh, what's the answer? You're getting for bro, sir. I'm getting 69, sir. 69.36.
Make any mistakes then. Sin 75 cos 75. It's correct, no?
Sir, maybe the whole problem is multiplied by 4, I guess.
No, no.
Like 4 into sine 40, 75.
Yeah.
Yeah.
4 into sinus in numerator. Yeah, I'm getting 43.76.
Getting 69. Bigger is only right. I'm getting 69.
So, do you have P by Q in your calculator or are you doing it like this?
So first what I'm doing is that I'm finding 4 sine 75. I'm finding the
How
answer
much?
for
How much?
that.
How much did you get?
4 sine
What is the answer you
uh,
got?
so 4 sine 75 is
No, no, no. 1 minute. 1 minute. 1
3.8.
minute. Can you tell me what answer you got? Did you get 66?
Yeah, 60 something.
So what you did is here. You can see. Can you see the screen? You have made
Yes, sir.
this
What did
mistake. If you take plus like this, it will not go in denominator. Okay.
what plus, sir?
Can you see this calculator on the screen?
Yeah, I can see it. What did I'm checking out what mistake I did.
Let me make it big, large. So what happened was you're supposed to take this in the denominator. Okay.
Okay.
If you take in denominator, you are getting 43.76, right?
Okay.
But what you did was you didn't use a bracket, because of which it went in the
No,
numerator.
sir, I use the bracket too.
But denominator, one more bracket you have to use.
Sir, I first found out the answer for numerator, then I divided it with denominator.
Hmm. So
So,
while dividing, you have to be careful.
so
So
4 sine 75 is 3.86. Okay. Divided by,
this entire thing you have to put it in a bracket.
oh, okay. So 3 plus 4 cos 75. An inverse answer. Yes, sir. Yes. Okay. Now I understood.
Hmm.
Okay.
I think your
Now it's
calculator is single
43.
line, huh?
Mm,
Your calculator is having single line.
single line, yeah.
It won't display like this, right?
Yeah, it won't display
So
like
if
that.
it displays like this, there won't be any confusion. You can feed it in denominator, you will get it. But in
Mm,
single line, you have to be very careful, especially with denominators. Wherever you are getting plus or minus in denominator, you have to put an extra this one. Okay.
okay.
So we got 43.76. Now the next part is more difficult. Ready?
Yes, sir.
Next, we have to find the resultant between this resultant and F3. Okay,
Yes, sir.
so this is vertical. So first we need to find the angle between them. What is the angle between these two?
Uh, so that is
This
30.
will be 90 plus alpha minus 30. No,
Yes, sir.
alpha value is known, so find it. How much is that? 90 minus 43.76.
Minus 30.
No, sorry, minus 30. This should be plus, no?
So 90 plus, yeah.
90 plus this. 103.76.
Mm.
Now we need to use this as this thing. One more resultant you will get. This is the final resultant. Okay.
Okay.
Let us call it as R2. R2 will be
Mm.
equal to F3,
Root
which
of
is 3 square plus resultant. For resultant is 5.59. No? So
mm.
5.59 square plus 2 times 3 times 5.59 into cos 103.76.
176.
This entire thing taken the root. What do we get?
So 3 square plus 5.59 square plus 2 into 3 into 5.59 cos 103.76.
Not 3.76. No? I'm getting 5.68.
This was the resultant we got the last time.
How much did you get?
1 second, sir.
Second one. So it has to be less now.
Into
Less.
I'm getting the same answer, sir.
What is?
5.68.
This is negative now. Okay. So 5.68 is the magnitude. And then
Mm.
again we have to find angle. Angle, let us take beta. Okay. So
Okay.
beta, from where you want to measure, let's measure it from this angle. Okay.
Mm.
So beta will be tan inverse. So if this is the one, then you have to take resultant. So R into what is it? Sine of total angle. What is the total angle?
Total angle is
Angle means angle between these two. That is 103.76
76.
divided by the other force, that is F3, plus
Mm.
R cos 103.76. Okay, find it.
R means 5.68.
Yeah, R means 5.59. 5.59.
5.59. Okay.
Tan inverse R 5.59 sine 6 divided by F3. F3 is how much? F3 is 3 now. plus
Yes, sir.
cos 72.9 degrees.
Yes, sir. 72.9.
Okay, so the final resultant is 5.68 in magnitude and 72.9 degrees from negative y-axis.
Mm.
Okay,
But we got some 42 from how like the
in the PDF form,
last previous method. Yeah.
here in the PDF, final resultant 5.7 he is telling. So we got 5.7 now.
Okay.
If
Okay.
you round this off, you will get 5.7, right?
Yes, sir.
And angle is 15 degrees. I think he is measuring it from horizontal. So we have measured from vertical, right?
Mm.
If you take 90 minus this, you will get 90 minus 73. How much? 17 degrees.
Yes, sir.
It's near enough.
Approximately. Mm. Okay, sir.
Okay, so here we have four forces, right? No,
Mm.
four, no, five forces, correct?
Yes, sir.
And all the five
Sir,
forces,
sir, can we end the class? Oh,
we'll end it. So tomorrow
yes.
same time.
Tomorrow, like I have work, sir.
Okay.
But can we have the class more in the morning, if
Morning
possible?
can not take it actually. I have another class.
Okay. Then no problem, sir. We'll have it on Monday.
Yeah,
Like I'll try to maintain the class properly.
okay, fine. Yesterday you didn't join, huh?
Sir, yesterday I texted Shamili and I told her like, can you take the class tomorrow? It's like now.
Mhm.
And then Shamili told me that okay, I will forward this to Srikanth sir,
Yeah,
and then I
I
will tell.
saw the message a little late, and by the time I joined,
Yeah,
nobody was there in the.
yeah. So like I was waiting till 5:10 also, like till I would say like till 9:40.
Yeah,
But afterwards, I thought okay,
maybe
fine. We need
15 to
to.
16 minutes late I joined. Later I asked Shamili also. She tried contacting you. Maybe you didn't
Yeah, I
receive.
was like then I went outside, sir. So that's
Okay, okay, no problem, no problem. So, maybe any other day possible, Sunday or
yeah. So probably Saturday or Sunday we can have class. No, no problem.
let just message it to Shamili.